The Endress+Hauser Overfill Prevention System takes your safety and efficiency to the next level. It enables you to maximize the utilization of your tanks, resulting in saving you time and money. When planning to revamp your safety instrumented system, you want to comply with the latest safety guidelines and standards. But you question whether you have interpreted the recommendations correctly and have designed and implemented the API 2350 and IEC 61511 standard conformed safety loop. With the Endress+Hauser standardized overfill prevention system, you can rely on our experience of designing, engineering, and delivering safety packages. The system consists of the sensor and the control unit, which result in a manual overfill prevention system. Alternatively, you can install a completely automated overfill prevention system that includes, over and above the sensor and control unit, an actuator, which makes it a safety instrumented system. With the standardized overfill prevention system, you receive a safety integrated level SEAL 3 capable system, which is validated by a third-party safety consultant. This assures you proper testing of the design by an independent body. SEAL demands regular proof tests of the safety device. Dismantling the instrument and testing it in a medium of comparable density is a typical proofing method. This often involves very high costs and is usually not possible within the required test intervals. Furthermore, your operational staff have to climb stairs to reach the tank roof and be in hazardous areas. Endress+Hauser offers a unique TÜV-approved proof test, which does not require anyone to be at the instrument on the tank roof. This increases plant availability and reduces costs at the same time. Let us demonstrate how you can perform a proof test of 16 tanks within 5 minutes directly from your non-hazardous control room. You simply start the proof testing procedure by pushing the button. You will then get the Proof Test Running alert. In the first step, you're testing the level transmitters for the high-level alarms. The green field indicates that all safety devices have passed the proof test. The next step tests the level instruments for the high-level warning. Again, the green field indicates that all safety devices have passed the proof test. Thereafter, the test checks general system status, for example, UPS battery, DC power supply, external alarm flashing light, and external alarm siren. Endress+Hauser has been attentive to details. For example, an external alarm siren with a built-in microphone to confirm the functionality. Of course, there are also functions that nevertheless require human interaction. The system asks the operator if the green status light is continuously on. If yes, this has to be confirmed. The system also asks the operator the following questions, all of which need a response. Is the amber warning light continuously on? Do you hear the warning sound? Is the red alarm lamp flashing? Do you hear the alarm horn? The final step of the proof testing is the printout of the result. The system also has to reset the proof test interval. In this case, the next proof test has to be executed in 365 days. This complete proof test of 16 tanks was done in less than 5 minutes. Bear in mind that the entire proof test was done from the control room without any process interruption. With this procedure, we fulfill the guidelines of the API 2350 standard. We are independent of the automated tank gauging system. The logic solver is protected against unauthorized modifications. And we have a documented proof test. Endress+Hauser has also implemented a clear text message to enable the operator to identify the source of any error immediately. In this case, we have a failure of the power supply. You will immediately receive a clear text message that the power supply has a failure, enabling you to take the necessary measures without wasting time looking for the error. To make sure that all the components of the cabinet work properly, Endress+Hauser has also built a temperature sensor into the cabinet to log the high and low temperature warnings. It's very important to have a proper working temperature in the system. If this is not the case, it could, for example, reduce the capacity of the UPS battery. The interaction between the safety controller and the liquefant sensor was optimized in this overfill prevention system. The vibronic liquefant fork from Endress+Hauser reduces your risk up to 48,000 times. Liquefant has proved the reliable detection of high-level oil in thousands of applications. Even buildup, as in this example, toothpaste and foam, does not lead to a malfunctioning of the safety device or to an unnecessary shutdown or false alarm. As you can see, even in conditions that might cause float switches to fail, the liquefant works properly and only detects the liquid level and triggers an alarm when the liquid reaches the height of the high-level alarm. Increasing safety and efficiency are not the only advantage of the overfill prevention system. Implementing an automated overfill prevention system can reduce your response time, for example, from 20 minutes to 1 minute, compared to a manual overfill prevention system which relies on human interaction. A 20-minute response time for a manual overfill prevention system includes, for example, communication time between detection of the alarm and notification of the staff, time to analyze the situation, time to complete the countermeasures, for example, closing the valve, time to verify that the process is in a safe condition. And in addition, a safety factor should be included as described in API 2350, whereas an automated overfill prevention system typically closes the valve in less than 1 minute. The improved response time directly increases your tank capacity because you can set the high-level alarm and the corresponding maximum working level closer to the critical height, which means that you can increase your tank working capacity. This means that instead of constructing a new tank, it might be sufficient to install an automated overfill prevention system with shorter response time, which saves you time and money.
During the review meetings, we go deeper into what the standard asks, and we're going to check, for example, the design and the software application, whether everything is designed the way it should be. Once the review meetings come to a conclusion that yes, this design is actually still capable, then we ask, in this case, Endress+Hauser, to put a system together so that we can go and start testing it in the factory. And during the factory acceptance test, we do all kinds of tests, not only from a functionality point of view, but also how the system behaves in case of failures. So does the diagnostics that they were promised to us actually work or not? Once the safety system is installed, the overfill prevention system, the customer needs to make sure that they operate, maintain and repair the safety system in such a way that it stays still compliant. In practice, that means that they need to have procedures in place on how to proof test it and when to do maintenance and repair. But this particular overfill prevention system helps them because it has an automated proof test procedure. So the customer will know when it's the next time that the proof test will take place, and it is automatically logged and documented for him. So in the end, in this particular case, the customer only needs to worry in case there is a repair needed. Everything else runs automatically.
With the assessment, verification, and documentation by the third party, we achieve Seal 3, and therefore fulfill the IEC 61511 standard. This standardized overfill prevention system is the result of state-of-the-art engineering and design know-how from Endress+Hauser, based on 60 years' experience in process automation. In addition, tests and certification by an external safety consulting company assure you tremendous risk reduction and protects your life, assets, and the environment.
Good afternoon, everybody. Welcome to this week Overfill Prevention Seminar. My name is Hanh, Regional Solution Business Manager of Endress+Hauser International, Asia Pacific Support Center. I have been in oil and gas for 12 years, and thank you very much for joining me today. Today, I will take you through the seminar. If you have any questions along the way, please feel free to put them in the question panel, or you can send me the chat message on chat box as well. Once I go through the slide, I will try to address to your question as many as I can during the hour that we have scheduled. Supporting to me today, my colleague, Mr. Linh, he will help me to collect on your queries and try to facilitate as much as we can. So without further delay, let's get on the seminar today with the topic of overfill prevention system for tank farm terminal. Before starting the presentation, we have small game. Would like to your participant. The game will be the menti.com page, which you see on the screen right here. You just go to Google, type in the Menti, and then let's participate with that small game. Now, please have your iPhone or laptop, just type in Google Menti, and then we will try the game with given ID. All right. Can you see the screen? Have you tried with the menti.com? All right, perfect. I see. Yeah, some participants already give answer. Perfect. Yeah. Then we go to the next question. What are standards for overfill prevention industry? Yeah. API RP 23550, IEC 1611. Yeah, some of you still have answer for that. Yeah. Thank you so much. Yeah. Yeah, let's move on with another one. And we'll see. All right. What is the more challenging in operating overfill prevention system in your plant? Yeah, very good. We see some answer.
Just one thing. For all participants, I'm sorry to interrupt you, Han. That we can let a bit over 5 minutes for everybody that can voting, and then we can move to the next slide. Okay. Let's just give them some time to put in their answer. All right, thank you.
Thank you. Very good answer. Yeah. Sensor malfunction, manual overfill prevention. Yeah. Thank you for the answer.
So for whom you cannot access, you can go to the menti.com website, and after that you will be asked for the code, and then you please put in the code 8218346 that I already put in the chat. Then you can log into the game, into the questions. Okay, for those who cannot access yet. Sorry again for disturbing you.
Right. Yes, some more answering. All right, I think very good answer. Yeah, those are overfill, fighting right level instrument type, manual overfill preventions. Yeah, that's a very valid answer. So we move on to the next question. How long does it take you to do complete proof test the overfill prevention system? That will be chosen for you to choose. One answer will respond in 2. Thank you. Thank you for the answer. Anybody do it in 5 minutes for overfill prevention proof testing? All right. So the answer, do it in 1 day and in 3 hours. Thank you so much. Yeah. Thank you very much for your participant in answering the question. Yeah. We see there are some challenging. We see there are long of time that we do for the overfill prevention. Right. And now let's go to the seminar today. So for the bonus, we want to talk about what is overfill prevention system. One of the most significant risks as facilities with storage hazardous levels is overfill event. Overfill event create significant level of risk because of overfill storage tank occur often and increasing the probabilities of overfilling. The severities of an overfill event may have high because of the health, safety issues arise on the environment is damaged, the fire from the law and from the government, and in the worst case scenario, it is a risk, even a scenario that the vapor may be exposed because of all the fuel there, and this causes devastating both internally and externally of the offending company. An overfill prevention system is a facility to detect, to indicate, and prevent the fluid level in storage tank rising up to the hazardous overflow. Because of that, prescriptions of best practice, safety relevant parts such as an overfill preventions are usually covered by a system operating independently of the process control. And today, additional requests is safety integrity level are often used to achieve a legally binding level of risk, reducing in easily comprehensive process. And for recent year, we see quite a lot of loss because of that overfilling, about some $1 million in damage of the facility work well, and also the loss of assets and the image of that company. Right. So where are the industry that the overfill prevention system may apply? And you can see right here, the oil and gas is majority industry that they're dealing with the overfill preventions, chemicals, primaries, life science, food and beverage, and also in power and energy. Those are industry which have very high intensity explosion products and very high value in terms of money. So those are the applications where the overfill prevention should have in their facility. And what are the main applications? The tank type that we can use with overfill prevention, right? If you look at in the right-hand side, there is a tank farm depot or product storage. This can be in refineries with the bulk storage, oil or gas, or even with edible oil and palm oil in the food industry. And also, yeah, chemical and hazardous liquid. And also in airports, they also need that the overfill prevention system to make sure that fuel is filling enough, right? So what are the tank type able to use with overfill prevention system? Many kind of tanks is go with fixed roof tank or floating roof tank, as you can see here from the terminal, and then spherical tanks also can possible, and bullet tank is also possible. And in some case, boiler, they also need that overfill prevention and distillation column as well. Then now we talk about the background. Why is an independent overfill prevention system needed? This is because of accident caused by the tank overfilling. Here are the photo that nobody wants to see, but actually it's what happened, right? On the left-hand side, you see that the liquid overflow on top of the tank, and then on the right-hand side, there is a huge damage, a huge fire, then high black smoke and fire. And nobody wants to see that, but a faulty fuel gauge can fail to alert the operators at any storage depot. That storage tank is being filled to a dangerous high level. Eventually, a large quantities of hazardous liquid overflow from the tank and causing environment damage, and even formation and ignition of the vapor cloud, followed by series of massive explosion and fire that last some day. And the result that resident insurance system methods, they request that overfill prevention system to be taken into place. And it will be combined between the standard API 2350 descriptive standards with IEC 61511 for functional safety. In addition to meet those requirements and standards, that is the pressures on the operation side, because of the system need to be frequently maintained, and the people who maintain the system need to be competent, so the training costs for the operator, for the operations, and also to have the maintenance costs and downtime is less. So those are the criteria that make the supplier and so also the operation think about that, right? And now we look at some case which was happened in UK in 2005. There was a big fire on the terminal in Postville oil storage depot, and it's caused totally lost about 700 million pounds for that damage, that fire of the terminal. In the left-hand side, you see here this very high smoke, and the right-hand side, yeah, after the fire, everything is collapsed. And this problem is caused over 40 people were injured but fortunately there was not any fatalities, and significant damage to both commercial and residential properties, and it guessed this area to be evacuated on emergency service. And the fire burned for several days, destroying most of the site and emitting the large cloud like smoke into the atmosphere. And the reason for those overfills was with high probabilities the failure of level measurement and the independent overfill prevention system. Although the failures of device, the level measurement was apparently the liquid filling without changing for nearly 3 hours, and the operator personnel did not take any action. Then it's caused overfilling and it's got destroy everything. And the next one, what we'd like to share with you, there's a case in 2019. It's Capeco in Caribbean Petroleum. The CSP, they make an investigation about this failure. So now I would like to share with you that video to see how the explosion come and what is the root cause and what's the recommendation. Let's please have a look at the video.
October 23, 2009. A massive explosion rocked the Caribbean Petroleum Terminal facility near San Juan, Puerto Rico. Gasoline overflowed and sprayed out from a large above-ground storage tank, forming a huge vapor cloud which ignited. The explosion damaged nearby homes and businesses. Petroleum leaked into the surrounding soil, waterways, and wetlands. Fires burned for more than 2 days, destroying 17 of the facility's 48 storage tanks.
The CSB found that current EPA and OSHA regulations are inadequate to control the hazards from facilities like Caribbean Petroleum that store large quantities of gasoline and other flammables. As a result, the company was not required to conduct a risk assessment of the danger to the nearby community from its operations, and the company did not have to implement safeguards that could have prevented the explosion.
On Wednesday, October 21, 2009, Caribbean Petroleum Corporation, or Capeco, began a routine transfer of more than 10 million gallons of unleaded gasoline from a tanker vessel docked 2.5 miles from the facility. The only storage tank that was large enough to hold a full shipment of gasoline was already in use. As a result, Capeco planned to distribute the gasoline among 4 smaller storage tanks. This operation would take more than 24 hours to complete. During transfer operations, one Capeco operator was stationed at the dock, while another monitored valves controlling gasoline delivery at the terminal. At noon the next day, October 22nd, the operators diverted the gasoline into tanks 409 and 411. Capeco used a simple mechanical device consisting of a float and automatic measuring tape to determine the liquid level inside the tanks. An electronic transmitter card sent the liquid level measurements to the control room, but the transmitter card on tank 409 was out of service, so operators were required to manually record the tank level readings once every hour. At 10 p.m., the night of the 22nd, as tank 411 reached maximum capacity, operators fully opened the valve to tank 409. At that time, an operator read the level of tank 409 from the side gauge and reported it to his supervisor. The supervisor estimated that tank 409 would be full at 1 a.m. But shortly before midnight, tank 409 started to overflow. Gasoline sprayed from the vents, forming a vapor cloud and a pool of liquid in the tank's containment dike. The CSB determined that a total of nearly 200,000 gallons of gasoline, the equivalent of 20 full tanker trucks, was released from the 6 vents on the tank. On a warm, windless night, the gasoline vapor cloud grew to cover an area of 107 acres. At midnight, The tank farm operator was ready to perform the hourly check of tank 409. But before reaching the tank, he noticed a strong odor of gasoline. He alerted the dock operator to shut off the flow of gasoline to the tank. The tank farm operator and another operator met the supervisor at the edge of the terminal. There they observed a white fog rising approximately 3 feet above the ground. The supervisor sent one operator to the security gate to stop anyone from entering the site. Then the supervisor and the tank farm operator drove to an elevated point away from the cloud to try to identify the source of the leak. Meanwhile, the pooled gasoline flowed through open valves in the containment dike toward the wastewater treatment area. There, the vapor reached electrical equipment, which ignited the cloud. A flash fire raced back toward the storage tanks. 7 seconds later, there was a massive explosion, registering 2.9 on the Richter scale. The time was 12:23, approximately 26 minutes after the overflow began. Soon, 17 of the facility's storage tanks were engulfed in flames. Fortunately, the 3 Capeco employees escaped the tank farm, and there were no fatalities. Flames from the explosion could be seen from as far as 8 miles away. The shock wave damaged approximately 300 nearby homes and businesses. Fires continued to burn for over 2 days.
The CSB determined that Capeco had an unreliable system for monitoring and controlling the level of gasoline inside the storage tanks. This set the stage for the incident.
The CSB found that the float and tape measuring devices used by Capeco were prone to mechanical failure. These devices were poorly maintained and were frequently not working on multiple tanks at the same time. Also, the CSB discovered that lightning strikes and cable breakages often disabled the electronic transmitters that sent tank-level measurements to the control room. Capeco routinely took weeks to repair problems with the level monitoring system. Instead, operators checked tank levels hourly and manually calculated the time it would take for tanks to fill, potentially introducing errors.
We found that the float and tape measuring system was the only control system Capeco used to avoid overfilling a tank. When that system failed, the facility did not have additional layers of protection in place to prevent an accident.
Phil Myers is a nationally recognized expert on above-ground storage tanks who assisted the CSB investigation team.
The concept of layers of protection has to do with safeguards that are in place to prevent an incident. Most tank filling operations are, for the most part, governed by a single layer which has to be backed up with other layers.
The CSB notes that good engineering practice would have called for at least 2 additional layers of protection at Capeco, an independent high-level alarm and an automatic overfill prevention system. An independent high-level alarm can detect and alert operators to the danger of an overfill, even if the primary system for measuring the tank level fails, as it did at Capeco. An automatic overfill prevention system goes even further and can shut off or divert the flow into another tank when the tank level is critically high. The CSB investigation concluded that if both of those systems had been in place and had been properly maintained, this serious accident most likely would not have occurred. But the CSB noted that petroleum storage facilities are not regulated under the same process safety management regulations as oil refineries and chemical plants, handling the same flammable chemicals.
There are thousands of terminal facilities around the country storing gasoline and similar flammable substances, often near highly populated areas. That's one reason why these facilities should be covered under EPA's risk management program, which would require those companies to develop off-site consequence information to allow the public to learn about potential dangers.
Also, the CSB discovered that current EPA requirements under the Clean Water Act only require that petroleum storage tanks have a single layer of protection to prevent an overfill. In the United Kingdom, in
Right. Thank you. Thank you for watching the video. Now let's continue with that. This, because of the wrong estimation, that caused a huge damage for the company. And this will be the most expensive that the operator have to pay for because of this wrong estimation calculation of free tank space and also the low maintenance of the terminal, right? So after all, those are affected to the industry, and this is request the industry with higher safety standard. The Overfill report is recommended for design and operation the fuel site, and then API RB2550 is also request for overfill protection and storage in petroleum facility, and also IEC 61511. This is request of functional safety for all the design. Now let's have a look to that Overfill report. It's request for a physical and electrical separate independent component or system for overfill prevention. And those systems must be frequently proof tested. And the advanced sensor need to be there is capable of online diagnostic and able to do function tests without filling the tank, which costs a lot of money and effort to do that. And it's also referred to the functional safety of IEC 61511. Right. And in API 2350, the system requested that it must be proof tested and documented. So whenever it can be traced, and by the insurance companies to trace for that, or by the operation, it needs to be proof tested and documented. And the system must with the uninterrupted power supply system. So wherever the power supply off, then still have backup to run the overfill prevention system. And then again, it is also requested separate from any device or method of tank gauging to make sure that if the tank gauging fail, then the system still work and independently. Yeah. And the common cause failure between overfill prevention and the tank gauging system should be minimized due to this is separate system and it's not affected by the failure of the tank gauging. Right. So it's also with the industry affect the IEC 615 is request of the functional safety, which is the safety integrated level of the device. So now look at to the safety layer. So basically we see that the first layer is the process control, where the tank gauging is there. All the parameter of the tank level, pressure, temperature is displayed in the system and in the control room. So it reaches to the point of higher level, then there's an alarm from the tank gauging system. And from here, the operator can trigger that safety system. But if it is over the tank gauging alarm level, it's go to high alarm level of safety from overfill prevention system. The overfill prevention system will trigger that activity, either to shut off the valve or turn off the valve or divert the flow to other tank to make sure that the facility tank fund to be safe. And if above that, there's other activities, active protection layer will be activated, which is nobody want to have in this kind of system. Right. So with all the requests of the standard, the overfill prevention system should be meet that requirement, and we can say in all the picture here, which is IEC 615 for risk assessment for safety level, and API 2350 for operation parameter and also management system, and then Overfill report is culture and leadership in managing the overfill prevention. With that request, Endress+Hauser, we have an everything integrated system here in the cabinet, which is included on certificate from API from IEC 61511, and then those are completely built and delivered to the client with small screen for the touch screen and with the display to let the status of the system, and also the siren and the light to let the operator know the status of the system. To have that Endress+Hauser, we we have from very basic setup, which is not a seal level, and up to completely beautifully with the SIL 2 and SIL 3 certificate SOP 600, where it can handle up to 16 tanks for high alarm and high warning. And then SOP 300, this is another design with the same safety loop of SOP 600, but it can handle up to 128 loop with high, low alarm, and high and low, and also with the leakage detection. But this system is not a seal rate system because of some component is not have seal level, and the system can cover very much sensor from radar, from servo, or level switch, or any other third-party supplier where we have before 20 mm communication. Now let's have a look about the safety instrument and the seal certificate. Yeah, you see from the process up to sensor, and then to transmitter, safety I/O, logic solver, and then safety I/O relay and actuator. All these kind of component we have all the seal certificate, which is small blue here. So make a combination of those seal certificate and the entire system we have with this seal certificate in this case. And we have, this is for SOP 600, which is Endress+Hauser we have. And now with the same setup, but some of components, they don't have the seal level. So this entire system cannot be seal certificate. And in this case, the SOP 300, which is a larger application, but then some client don't request a complete seal level, then this is a choice for client. Right. Now, and this is how the system will look like. On the yellow color here, you see, this is the level switch. This will be connect with the overfill prevention cabinet, and from here there will be the data output, the signal output, which is to the horn, to the flash line, and send data output to also emergency system for to shut down the valve. And also there is a leakage detection. It can connect to the overfill prevention system. Yeah. The same design, same concept, it's only different that all the components in the system are seal level. Then we have a complete safety instrumented system with SIL 2 and SIL 3 for automatic overfill prevention system for SOP 600. The overfill is not come only from the top of the tank, but it is also leakage may occur from bottom of the tank. So the combination of the leakage detection and overfill prevention, that would be the best solution for the terminal. Now, when the deliver of SOP 600, the size and the layout is very dependent on the project set specific. Inside there will be a safety PLC, which and with the level tester for the logic solver, and this will connect on the sensor from the field. Then the flash line and the serial will be delivered together with the UBS and temperature sensor inside the cabinet. The small display to let the operator to know the status of the cabinet of the overfill prevention system. Now let's look into the interface, user interface and alarm. So if there is only blue and green color on the screen, then it is in perfect condition. Everything is smooth operation. And if just a red color appear on the screen, there's something wrong. And for example, in this case, the tank 125 is at high level, then the operator needs to take action. And for the orange color, then the system is under proof testing. Yeah, the interface varies and friendly for user. Now, it's about the total proof test coverage according to IEC 61508. This is required that the system needs to be proof test. Let's talk about the procedure. For example, now we have 16 tank, and the tank is about 20 or 30 meter high. What we need to do for the testing? The first thing come to mind is will be the wet test. That means we have to check if the device will be switched in case it gets covered within the media in the tank or in similar property. We can do either by, for example, we need to fill the tank up to reach to the point level, and this will cost a lot of money and time and effort to fill it up just to test for only the level switch. And another one is just remove the point level here and we put into the bucket with similar of medium just to check for that. To do that, those are not the good idea, because if we're dealing in the harsh condition, that would be potential of risky for the operator, time and effort for the people to do one by one, and also maybe it's get damaged the device due to improper handling. And usually it will take about 30 minutes to do proof test for one tank, and if we have 16 tanks, then it's already some hour it needs to be done, which is I see one of the response from audience is about 1 day to take on those kinds of proof tests, right? So with the automatic proof test, life will be easier. It's just 5 minutes for 16 tanks, and it is in the set area where you just sitting in the control room, press the button, and the logic server will run, and it get the data back and forth from the level switch, and the proof test will be done, and the automatic documentation will be documented after the test. Not only with the fast proof test, but also is the response time, is the react, right? So with the manual overfill prevention, the reacts will take a long time. So people can go to the site, check in the level, and you will go back. Then you continue with the filling. But with the automatic proof test, yeah, the react is less than 1 minute. You can save a lot of time. Then even invest, you don't need to invest more time, because you can manage to load more products on the tank to certain level because of that capacity storage and also the fast response time for the liquefy. Yeah, so here are some benefits for the client to have the overfill prevention system with completely sealed certificate, and this would have the system to be certified not only for the operation, but also this is for with the insurance companies where the system is have a sealed certificate, and is also do automatic proof test, save time, effort, and safe for the operation. And also warning will be there. Anything, the light, the siren will be there, and the operation will be alert. And especially on documentation, on the procedure, on the test, is to be logging and documented. Yeah. So this is also possible to get at the remote access, and very fast and very economical support, right? And this also customized for future upgrading, move from 1 tank, 2 tank, and up to scale up to 16 tank with SOP 600, or up to 128 tank for future expansion with SOP 300. And this can be fit with oil leak detection at bottom of the tank as well. So what Endress+Hauser can do with the overfill prevention system for the client, if you look at this, the entire system from the level switch is connected up to the cabinet, and also we can deliver together with the actuator when client requests. So entire solution is to be provided by Endress+Hauser, from the design, from procurement, from the site support, commissioning, everything. Yeah. Right. So to have that system, the safety system is always request for the terminal, and that overfill prevention system should be independent and is diverse system, which is it will be separate from the current tank gauging for higher safety level, and it is also can be remote and automatically proof test, and this is also less. It will cost increased capacity. And nowadays with the development of cloud solution, yeah, all the data can be stored on cloud, and then from there you can do all check-in, testing, proof testing, which is based on cloud solution. To be installed a seal certificate overfill prevention system, the insurance cost may be reduced. And using the automatic overfill prevention system with the high alarm, this can be higher up, and this saves money by increase the tank working capacity. This is the beautiful of using the automatic and fully system of overfill prevention. And here are the supporting that Endress+Hauser we can provide to the client. Very basic, from very rough idea up to hand over to the client with complete process from Endress+Hauser. So there are some applications that we can support. It is from simple system that only the level switch up to the cabinet here, and all it can get the data, the signal from the engaging migrate into the overfill prevention for another layer of protection, or even with the complexities of the system. You see here that this is an uploading process from the ship to the tank. So where the overfill prevention system will send a signal to shut out the valve at the pipeline and also at the ship to make sure that the loading process in safe area, in safe condition. Here are some projects that we have done in the region. Customer very happy with those performance, and even from the airport up to the terminal. This is one of the projects in Cambodia we did with complete CO2 overfill prevention system. And right here you see this cabinet, pretty high, and all with the flashlight and the horn there, and the small status say that all good condition of the proof test, and this is 364 days left for the next proof test, which is just done today, and you have 1 year for proof test again. Right? And aside, there is a separate device. This is for the level switch, directly connect with the overfill prevention system, and this is the engaging system. It can share the data signal to overfill prevention as well. And this is in our projects in South Oman. It's for 14 tanks in Oman for overfill prevention, and this is CO3 level. And this is another in the airport in Dubai, which is for 5 tanks. The client had planned to increase it for the future. That is all the overfill prevention system today that we would like to introduce to you. Now it's time. If you have any questions, feel free to let us know. Thank you for your attention.
Okay, so thank you for your presentation, Mr. Hanh. Currently, we have some questions that I will spit out for you, and then you can answer here. So the first question is, does OBS applicable also to granular product like clinker and cement?
Thank you, Linh. In principle, the overfill prevention system is work based on the bicarbonate level switch, which is also possible for liquid and also for the bulk material. So in this case, it could be workable for that clinker or that bulk material.
Okay, thank you. So the next question is, which API standards is for OBS?
The API standard for OBS is PR2350 API standard, which is international standard for overfill prevention system.
Okay. Next question is this easy to install? I mean, this system, is this easy to install?
That is not so difficult. The system consists only the level switch on top of the tank or bottom of the tank, and the power supply is from the cabinet, so only 2 wire cable connect from cabinet to the side. So that consider is pretty easy to install on the tank from the side to the control room.
Okay. Okay, thank you. The next question is, what are Endress+Hauser hygienic products?
For hygienic products, in this overfill prevention system, the component who would touch to the hygienic products would be level switch, which is we have the model FTL50H or FTL51H, the liquid fan to touch with that hygienic products.
Okay. Okay. So the next one is, we have this question is a bit long, so I will read one by one for you. The first one, what are the main action from the engaging system?
Right. The tank gauging system, its purpose is for inventory purpose, and for in the tank gauging system there will be product level, do mass calculation, the trending, reporting, tank grouping, temperatures, pressure. Yeah, this is for inventory purpose with further information, and also it's go for custody transfer.
Okay. The next one, are the input valves of tank directly commanded by tank gauging?
Normally, the valves that will receive the signal from DCS to close or divert the valve to other tank. So the tank gauging, they will send the alarm to DCS, and the signal that must be from DCS, is not from tank gauging.
Okay. Is there any need for additional devices for overfill protection other than tank gauging, or is this enough?
According to API 2350, Overfill report and IEC 61511, the overfill prevention system should be independent from any method or any device from tank gauging. So to make it a complete and certified system, an additional device beside the tank gauging is the level switch, and the overfill prevention cabinet is needed. And I see some clients, they also get a dual output from the tank gauging system to the overfill prevention cabinet for the high alarm also. So to be complete and to be certified, I suggest that to have a separate device from tank gauging for overfill prevention purpose.
Okay, very clear answer. So the next one is, I would also want to know the accuracy level of tank gauging.
The tank gauging, we have two kind of, one is for inventory and one is for custody transfer. For custody transfer, as according to OIML, this is recommended that in application, the accuracy would be plus or minus 4 millimeter. And for inventories, the accuracy is plus or minus 25 millimeter in application. And in the production condition, the level device itself can achieve the accuracy is up to 0.4 millimeter with a servo technology and 0.5 millimeter with radar.
All right. So the next one, how popular of having OBS in oil gasoline tank farm today?
That would be an interesting question. Nowadays, we see it's more than 60% of the terminal and tank farm, they have a kind of overfill prevention system. They use, most of the time, they use the easy combination and get dual output from the tank gauging system and to the DCS for overfill protection. And still not so much client, they use completely certified seal and independent system like what we propose. So we hope that they will be growing. They will be growing in this application where the safety level will be high and the protection will be higher for the client as well.
Okay. So the next one is also continue to these questions. What's the available technology in the market? Any local and international authority to certify for this system?
We come across to the region. We say most of the client, they apply the international standard like IEC 61511 and API 2350 output report, and some country they have local standards as well. The common popular technologies in the market is still using radar for high alarm, and then vibronic level switch is for high alarm for the overfill prevention system.
Okay, so we have some more questions. So now the next one is how we know if our system has an automatic overfill system in DCS. Okay, I repeat again. How we know if our system has an automatic overfill system in DCS. So I think I'd like to know if in the DCS, how can he know that in the site you already have the overfill prevention?
Right. That would be the hardware setup aside for the automatic overfill prevention system. Like we saw there, this is the logic control and the field connection, and then those output from the cabinet is sent to DCS. If outside there is no automatic system, I don't think that in DCS is we saw the automatic overfill prevention system there.
Okay. Okay, the next one. I'd like to ask what is the most suitable instrument for above ground LPG tank that should connect to a SOP alarm panel? Servo level, or it is okay to use a pressure transmitter instead? Okay, I read again.
For LPG application, servo technology would be the most suitable because it does not affect by the vapor of the LPG. And recommendation is using the servo as a primary level measurement for tank gauging, and then for the overfill prevention, the vibronic, the 24, it should be the device to detect overfill in the system. And I see some case, just some special case that client, they also use pressure transmitter also for overfill prevention system.
Okay, the next one, this automated overfill system is connecting to DCS system or tank farm management system, or we need to plan another system. So I mean, he asked for the connectivity of the overfill prevention to connect to the DCS or to connect to the tank farm terminal system or another system.
Right. The overfill prevention system is an independent system, and it sends the signal to emergency system for protection of overfilling, shut off the valve, divert the flow. Yeah. So this overfill prevention can also get the signal out to transfer to the terminal management system as well.
Okay.
So yeah.
All right. So the next one, what is the most suitable, I think, high alarm instrument for asphalt tank? Is it okay to use liquid fund FTL?
For asphalt, yeah, I think it would be suitable to use liquid fund.
Okay. But I just have the one recommend on this one, because we have asphalt tank is a bit cost. So maybe we can use also as well the secondary like the other radar system, but make it like the just the point level, like you measure with the radar, but you use the for the level switch only. In case it's very big cost, then you can, the liquid fund may have some you have made some do some more maintenance because it's a bit sticky. So then the alternative would be another radar, then you can use for the overfill. Okay, next one. Is there compatibility issue with other systems such as DCS, fire and gas engaging system? This is the questions. Again, I read again. Is there compatibility issues with other systems such as DCS, fire and gas and engagings?
Right. So you mean that is it compatible, right? This is again the overfill prevention system, which is an independent system. So whereas from here, it can trigger alarm by itself, and then also can send a signal to DCS. So from my point of view, that should be compatible, and it's not any conflict with other system in the terminal.
Okay. Next one. Oh, sorry. How is the automatic overfill prevention system connected to cloud? Any particular security requirements?
Well, from the overfill prevention system, there must be the edge device, and it should connect to the cloud via the Netilians. And in the Netilian, there will be a security layer to protect the data for the client. Yeah, it should be the edge device to convert the data and uplink to the cloud.
Okay. Is it okay to install a temperature probe even without thermal weld? I am referring to the asphalt product, which has around 200 degrees C product temperature.
It's quite sticky. So from my understanding, it should have this thermal weld to protect the temperature probe.
Okay. So I don't know if he referring to the multi-point temperature or the single point temperature. Yeah, but if the single point temperature, I think the thermal weld, we can also use this, or to first to protect the sensor, and then if you have the maintenance for the temperature device, then you can put it out without to stop being the tank, or have to rent out all the tank. Yeah.
Right. That's a very good question.
Oh, okay. They have the I think the question is the requirement to avoid a breach in security. I don't know what is mean about the security on the overfill prevention. Do we have any? Maybe I understand that. Do you have any method to avoid any other person to maybe malfunction the system?
Yeah, the system itself, they have the security layer for operator, for supervisor, to make sure that the logic server is to protect the outside attempt to the system.
Okay, so we have yes. Our internal protection for that.
Yes, correct. Yeah.
Okay, the last one, why point level switch is used instead of transmitter type?
This point, the signal out just for the on off, and this is the robust system, robust signal for the emergency, right? So the point level switch used in this case for the safety purpose, the highest safety standard instead of the transmitter.
Okay. Just one more question come up. Is the system can be installed even the tank is in service?
What kind of tank? If it's LPG with high pressure inside, yeah, definitely cannot. But for the tank with atmospheric, then following to the safety procedure, it can be done as well. Just only level switch for the tank.
Okay. So one more question, I think continue to the previous question. He asked why point level switch is used instead of transmitter type. And now the next question is, level switch will not have diagnostic feature unlike transmitter?
The sensor is the advanced sensor. They have the diagnostic function.
Yeah,
then
so
they can do.
Yeah, so we call the level switch, but not because of it don't have transmitter. They have transmitter as well with our liquid fund there, and they have also beside the transmit the signal or the switch. Then they can have also the how to say, the diagnostic, like Mr. Hanh already informed, to give you the alarm, and even that we have our liquid fund with some heartbeat technology that also can help you to see or to check if the switch is corroded in some cases without taking out to check.
Yeah, just one button on the link. Yeah, that can be done for diagnostic or for proof testing by itself.
Yeah. Okay. Currently, I don't see more questions, and it is nice that we have a lot of the question to your topic. So anyhow, now if I think the time is over, and very nice, thank you for all of your time to participate today section of overfill prevention. So Mr. Hanh, I give this the final speech to you, and if you have any sharing, so stage is yours.
Right. Yeah. So thank you very much for your participation. This is a weekend. It's taking your time for this seminar. We are very happy to have you here. So we wish you have a successful, and I hope to see you soon in the next seminar. And have a nice weekend. If you have any requests for overfill prevention system, feel free to come to us. Thank you.
Okay. Thank you, and have you a nice weekend. See you later in our upcoming webinar. Thank you and bye-bye.
Thank you and bye-bye.